Hey, and welcome to the Observer pattern. Instead of telling you what it's all about, I'm going to immediately tell you what it's all about. So before I even really tell you what these delegates or dynamic multicast delegates are, let me just show you how we're going to use them to give you some context. On our tank, we're going to have a property called onDeath that we can say broadcast. So we're going to broadcast the fact that the tank has died. That's going to go into the Unreal Engine. That's going to work some magic. And then the tank player controller and the tank AI controller can subscribe to receive this, and they will then be able to process it. For example, the player controller over here can then say, okay, I'm going to go into spectate mode, and the AI controller can stop trying to control the tank, given that the tank is now defunct. Okay, so that's generally how it's going to work. The broadcaster here, the tank, does not care who is listening, which observers are on the right-hand side. That's the general principle, the general pattern. So in your resources, I've given you a few links. I would suggest that you take a moment to go and read them now, as soon as I've introduced them. I'll tell you when. Read about delegates and find out roughly what delegates are. Don't go mad, just have an overview of this. Spend a couple of minutes. Then read about dynamic delegates. There's not much different. They can basically, well, it tells you the difference here. And then look about multicast delegates. And there are, again, some slight differences with multicast delegates. And we're going to be using dynamic multicast delegates, all of these layers on top of each other, this thing here. And the reason is that it's the most flexible and versatile and the most reusable. And I would start with that in general, and you can move backwards to simpler delegates when performance dictates you need to, or when some other constraint dictates you need to. But there are a lot of boulders to navigate in Unreal when it comes to these things, because there's various combinations are not possible on actors or components or exposable in Blueprint or not, etc. So I'm giving you one reliable recipe for getting these things working. So we just need to write a little bit of code on the tank and a little bit of code on the AI controller and player controller to make this work. Okay, so this is the steps of setting up dynamic multicast delegates, DMCDs. If you haven't already stopped and read the Unreal docs, those first 3 docs I showed you about delegates, dynamic delegates and multicast delegates, please stop the video and do that now. Okay, so this is how we're going to do it. On the tank, for example, or on the broadcasting type, we declare dynamic multicast delegate with some subject name. We just say F and then we give it a name. You then declare a property of type subject name called onSomethingHappened. I'll give you concrete examples in a minute. And then you broadcast onSomethingHappened.broadcast. So in the case of the tank, this could just be ftankDelegate, ftankDelegate onDeath.broadcast. You get the idea? On the receiver, we need to declare a U function. It won't work properly otherwise. And then you have to declare a delegate method. This is the method on the receiver, on the AI controller, etc., that will handle the delegate when it gets called. And for example, you'd say void onTankDeath. And then to register to listen, you do this. You find the broadcasting instance, i.e. the possessed tank, in our case, and then you say onSomethingHappened, i.e. onTankDeath, .add unique dynamic, this, i.e. the tank player controller, the AI controller, whatever. And then the class, for the class we're in, the player controller, the AI controller, the listener class. And then you tell it the address of, this is an ampersand operator, address of operator. You're saying go find in memory the delegate method, i.e. the onTankDeath, which we declared here. So what this guy does is it binds. It's the binding. It's saying this is where you need to go to find how to do that. But the question is, when do we register? Well, I'm going to help you with that bit. I'm not going to leave you to work that out on your own. That would be a tad mean. I'm at least going to do it on the AI controller for you. Otherwise, I'm being nasty. So if we look at the AI controller header file, it's a type of AI controller which in turn inherits and inherits again. And what we can do here is we can override something called setPawn. So virtual void setPawn, and then it takes in a pawn pointer in pawn, and I'm going to override it, override the superclass. Now this gets called when the pawn is possessed. Okay, so when the tank AI controller gets possessed, this method gets called. Let's now go and implement that setPawn, and I'll show you why, because that's where we are going to do the binding. This binding that I've showed you down here, this is where we're going to put that code, okay? And it's not fair for me to make you work out that that's where we should be doing it, because you'll find it just won't work if we try and do it at a different time, or at least it won't work reliably. We can't be sure that at begin play we have possessed yet. So we set pawn, a pawn pointer, in pawn, and then we're ready to go and implement the method. First thing we need to do is call the superclass, right? We're overriding here, so we want to call superset pawn in pawn. We don't want to affect, we don't know what the game engine's doing in the superclass. We've overridden. If we don't call super, then this whole thing won't get called on this object, and that's no good. Okay, so we've called super. Now, the next thing we need to do is we need to only do what we're going to do next if we have an in pawn. So one way to do that was to say if in pawn, and then we go into a block of code. Okay, if we don't have one, we don't even want to proceed. Then what we're going to do is we're going to go work out what the possessed tank is. And that is the in pawn that's coming in, so the pawn that this AI controller is possessing, but we need to cast it to a tank. Now, we can't cast it to a tank, of course, without this class knowing something about a tank, and that's fair enough. We are implementing a delegate that relates to a tank's on death event, so we need to include tank.h. That is quite normal. If you want to know why, then we can go up here and say why we've imported it. So we can implement on death. Okay. All right, so now that we've hash included tank, then this cast down here should work. Then we probably want an ensure statement. So we say if not ensure possess tank. Don't worry, you'll get a chance to do all this for yourself on the other side, on the tank player controller. If not possess tank, return. Because by this stage, we really ought to have a possessed tank successfully cast from the pawn. And then it's where we're going to subscribe our local method, we haven't written yet, to the tank's death event. And you're going to do that. Okay, so I'll put it to doing. All right, so this is where you do it. As I say, it wouldn't be very fair for me to expect you to work that out. Let me recap why we're doing it on set pawn, because constructor is too early. Begin play may race. By racing, what I mean is that we may or may not have possessed at begin play, and we don't want to take that risk. We want to explicitly only do this once the set pawn gets called. Okay, so that's the structure for you. Right, now, given that layout, what I'd like you to do is to go ahead and set up the whole delegate system, or as much as you can. If for beginners, this may be a bit much. For advanced people, and you may get it done. Use the crib sheet on the previous slide. I'll leave that up in a minute. Register the tank player controller and the tank AI controller to receive on death. By the way, if you want to reduce the scope of this challenge, just forget the tank player controller. Just do the tank AI controller. I've already started. At least get the tank AI controller done. Now, you want to receive that event from their possessed tank, like I've already set up for you, and then log to prove that we're getting the message. Okay, so we just want a log entry when our tank dies. When the AI tank dies, you may have a bit of fun trying to kill the AI tank as a minimum, and you want to log to say, okay, cool, it's dead. And if you want the extra challenge, then go ahead and do the same thing for the player controller. So pause the video and see if you can get that working now. I'm going to leave up on the screen this recipe for you. Okay, welcome back. So given our recipe there, let's go ahead and see what we need to do. So on the tank, we need to firstly, underneath here, hopefully you found this in the documentation, above the class, we need to declare dynamic multicast. Now, unfortunately, you get no help here from the autocomplete delegate. And I'm just going to call it ftank delegate. That's the type. And you do, unfortunately, need a semicolon. We never know with these things, but in this case, we do need one. Okay, now it's going to be a public thing here. And it's going to be of type ftank delegate. And then it's going to be on death. Okay, so this on death here is something that we can actually, in the C++ class, call. We can broadcast on death.broadcast. Instead of logging out to say the tank's dead, we just say broadcast on death, and then let all the listeners or observers decide what they're going to do with that. Okay, so we say on death.broadcast. Let's make sure that the code compiles to this stage. And while it's compiling, I'll show you what has changed on the tank. Just that, on death.broadcast in place of the log message. And on the tank header file, above the class, we have declare dynamic multiclass delegate and the type, and then ftank delegate on death. Okay, so that has compiled, but of course, at this moment, we are not going to know whether it's working. So to know whether it's working, we're going to need to go into the tank AI controller, and then we're going to need to subscribe our local method. So how do we do that? Well, let's go back to our recipe. We've done this, and we've even done that. So we're now below the line. We need a delegate method, a ufunction delegate method. So let's do that to start with. So it's going to be a private method. Remember I said it has to be a ufunction. if I can spell it right, in order for it to work. And then what name do we give it? Well, what does it say in the recipe? We call it the delegate method. Well, I mean, that's what I've called it, but on tank death is one thing you could do. I'm going to say on possessed to be really clear, tank death. So our local method is going to be on possessed tank death, okay? And that is what's going to get called. We have to have a method here. So let's make this on possessed tank death directly below the set pawn, I think, so we can see it. And then to turn that into a definition, we just need to, of course, put the class name in front and some squigglies. Okay, so now we have somewhere in memory that we can go, i.e. here, in order to use, or in order to handle the delegate when it gets called. So how do we do this? We say broadcasting instance on something happens. So the broadcasting instance I set you up with, that's the possessed tank. Okay, so we have the broadcasting instance. Now once the auto completes there, if we look through the broadcasting instance pointer and type on, we should have an on death. You see with all these other engine things on actor overlap, we've got on death. Ah, that's pretty cool. So possessed tank on death, then what do? Broadcasting instance on something happened, dot add unique dynamic. Now, warning, the system is not going to give you add unique dynamic. Unfortunately, as an autocomplete, you're going to have to type it yourself. Add unique dynamic on this, and then we need the function name. So we just put an ampersand in front of this stuff here. Okay, and that has now subscribed us. It said, okay, here's the instance. It's got this on death delegate that gets called. We're going to add a unique dynamic registration for it, and we're going to handle it using this method here. So to finish off, all we need to do is log to say that we're receiving this. Just say received like that. Okay, let's see if that works. I'll get it compiling. Remind you while we're compiling of what we've done. We've made an on possessed tank death ufunction method here. We've done our subscription, so I can get rid of the to do here, where we tell the possessed tank where to go to handle the death event, and then we're just logging to say received. Okay, so now what's got to happen, firstly, is I need to open the tank blueprint. Save, let's compile. It might crash. It's crashed because we've made a fairly fundamental change to the tank blueprint, and sometimes that causes crashes in the engine, so that's not uncommon. So let's reopen the tank blueprint. I'm just going to make sure it does compile. I'm now going to play the game. So the tank didn't appear to be aiming there. Let's go look at the tank blueprint and just make sure that it still has an AI class, and it indeed does not have an AI class. So let's reset the tank AI controller there. Compile and save the blueprint, and let's just play again. Now I'm hoping that he'll now aim at me, which he does appear to be doing. One strategy for just destroying the enemy tank is to get so close he can't find an aim solution, and then he won't fire because he's too keen to be precise. You need to be close enough that you can hit him, of course, but not so close that he can fire at you. And then what you can do at this stage is just keep firing at the enemy tank until it's dead, watching its health bar go down and its jitter, making any notes about any changes to your effects you want to make at this point, and now we're going to keep an eye on the output log. There you go, received. Fantastic. So we actually have that event system working, and there's no reason we can't just go straight ahead and do exactly the same thing on the player control tank now, but let's do that in another video because this one's plenty long enough. So hopefully this diagram makes a little bit more sense now. You've had an overview of how this works in fantastically useful general system. You can use it, for example, for achievements in your game. You know, when you get those unlocks pop up on your console or even your Steam achievements. That can be done like this. There's a lot of things that can be done like this. Please go and read Game Programming Patterns as linked in the resources, this observer pattern. Have a browse through this. Don't expect yourself necessarily to understand all of it, but it's a pretty good overview, and I will see you in the next video.